graph an inequality. We're to graph the inequality negative 2x plus y is greater than negative 4. And the first step is to rewrite the inequality in slope-intercept form. And so we are going to have the term with the y on the left side, coefficient is 1. We're going to have the term with the x on the right side of the inequality. And we're going to have our constant next to the term with the x. So if we go ahead and rewrite this inequality, what we're going to do is add 2x to both sides. And when we do that, we're going to get y is greater than 2x minus 4. So that's what I'm going to write here when I rewrite the inequality in slope-intercept form. It's going to be y is greater than 2x minus 4. Now we need to complete step 2, which is to identify the y-intercept, and that is going to be our negative 4. We're going to identify the slope next, which is the coefficient in front of the x. So we're going to have a slope of 2, or 2 over 1. Right. We draw a dot on the y-intercept on the graph. Just like as if it was an equation, we're going to start with the y-intercept negative 4. Our y-intercept is where the line crosses the y-axis. X is going to be 0. So I'm going to bubble in my first point at 0, negative 4. Next, from the y-intercept, we're going to rise or fall, right? Go up or down. 2, because remember our slope is 2, which can also be expressed as a fraction of 2 over 1. So our rise is 2. And our run is going to be positive 1. Okay. So we're going to go ahead and start at our y-intercept. And we're going to go up 2 over 1. I'm going to get to here. Step F is to repeat that and draw a third dot, which is up 2 over 1. And now it's easier to draw our inequality. So now what we want to do is take a look at what's the inequality symbol. Is it greater than? Is it less than? Is it greater than or equal to, or less than or equal to? And looking at our inequality here, it is greater than, right? So I want to put greater than there. Now what is the rule? It's use a solid line to connect the dots. If you have a less than or equal to or greater than or equal to symbol, use a dashed line to connect the dots if you have a less than or greater than symbol. You can see here we have a greater than symbol, so we're going to use a dashed line. Okay. So let's go ahead and draw this. I'm going to get some sort of a straight edge. And I'll connect my dots and draw my dotted line. Look like that. I'm going to draw little arrows on the end of my dotted line. And step H is to connect all 3 dots with a line, right? And so in this case, we're going to connect the 3 dots with a dashed line. Right? If the symbol was less than or equal to or greater than or equal to, then we would have connected the dots with a solid line. Now we're going to test a point not on the boundary line. Alright, so let's go ahead and test a point not on the boundary line. Let's use 1, 1. Let's use this point right here. So let's do 1, 1. If the inequality is true for the test point, then you shade the area that includes that test point. So we're going to use the test point 1, 1, and if the inequality is true, then we're going to shade all of this side. All right. If the inequality is false for this test point, we're going to shade this side of the graph. All right, so let's go ahead and try that out. Here is our inequality. It's negative 2x plus y is greater than negative 4. And our test point is going to be 1, 1. So our 1 is our x and our 1 is our y. We'll plug in our 1 and our 1 over here. So we get negative 2 times 1 plus 1 is greater than negative 4. Do some math here and do a multiplication and get negative 2 plus 1 is greater than negative 4. We'll get negative 1 is greater than negative 4. Is this true or is this false? Well, if you have trouble thinking about it, you want to look on a number line, and we'll have 0 over here, 1, 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5, right? Negative 1 is greater than negative 4. That's true. Negative 1 is to the right on the number line when compared to negative 4. So this statement here is true. Since it's true, what side of the inequality are we going to shade? We're going to shade the area that includes the test point. It's going to shade this side of the inequality. I'm going to do it like so. And that's how we complete these problems.